So as promised, we're going to spend the next little bit studying polynomials. So recall that Rx is the set of all polynomials with real coefficients. All right, and it's a ring, so Rx is a ring and not a field. And we know that, for example, because 1 over x is not in there. It's not a polynomial. There's no way to write that as a polynomial. It's a rational function. It has a polynomial in the denominator. So what we're saying here, just to remind ourselves of notation, when we used that square bracket, that was a ring. And when we used the parentheses instead, that was the set of rational functions. That was the field of rational functions, polynomial over polynomial. So this guy right here is things like p of x over q of x, where both of these are polynomials, and the denominator is not the zero polynomial. So this Rx is a ring. It's the ring of all polynomials with x as the coefficient, the variable, sorry. All right, so we're going to think about Rx, this ring, and kind of compare it to the integers. So we're going to compare properties of Rx to the integers, the ring of integers. So in particular, things that we studied for 1 here with z were the division algorithm. So that was where we wrote any a as b times a quotient plus a remainder. And that had to be greater than or equal to 0 or less than b. Okay, so we're going to do something similar with polynomials. Also in the integers, we had primes, and we had unique factorization. And so we're going to study that kind of thing here in our X. Which of those hold and how do we modify them to make them make sense in our X? All right, so I just want to do one quick reminder of how we divide polynomials. So if you remember how to do polynomial long division or synthetic division with polynomials, you can skip ahead. But if you don't, you should be able to catch on pretty quickly. I'm just going to run through one example, and then you can practice a few more. We'll need it every once in a while in this chapter. All right, so if I want to do out this division, so we're working toward a division. I want to divide this, and I want to figure out what the remainder is. I can do this with synthetic division. If you remember how to do that, I actually don't remember how to do that, but I do know how to do long division with polynomials, so I'm going to try that. All right, so one thing, I've got my x plus 1 goes into this whole polynomial. One thing I have to be careful of is I need to leave space for every possible degree here. So I need to put in a 0x to the 5th, even though I haven't written it down up above. I need to leave the space for it here in order to make this work. So now comes this I don't have, so I'm going to put it in. Okay, so there's my start to polynomial long division. Now, I'm going to do the leading term, the x here. I'm going to think about how it goes into each next term. So x into x to the 6th, I'm going to need that to be x to the 5th. So I put that on top, and now I need to multiply that x to the 5th by x plus 1. So I'm going to get x to the 6th, which is great. I'm going to be able to subtract those away, and an x to the 5th. And here's where it's important. We left space, right? So now I'm subtracting. I get no x to the 6th, and I get a minus x to the 5th. All right, and then I repeat. X goes into minus x to the 5th, minus x to the 4th times. So now I bring that minus x to the 4th times x, and times 1. and I get this, and now again I subtract down, so my x to the fifths go away. Now I'm doing minus 3x to the fourth plus x to the fourth, so I get a minus 2x to the fourth. Okay, so now back to x plus 1. X goes into minus 2x to the fourth, negative 2x cubed times. So now negative 2x cubed times x, negative 2x cubed times x to the times 1. I get this, and I'm going to subtract down. So my x to the fourths go away, and I get up at the top, I have a 2x cubed plus 2x cubed gives me a 4x cubed. Okay, so now x goes into 4x cubed, 4x squared times. That brings me 4x cubed plus 4x squared. Subtracting down, I get a 0x squared minus 4x squared. Okay, so x goes into minus 4x squared minus 4x times. All right, and then I get a minus 4x squared minus 4. Subtracting down, I get minus 5x plus 4x gives me minus x. X goes into minus x minus times. And then I get a minus x minus 1. Subtracting down, I have 7 minus negative 1, so that gives me 8. And that's my remainder. So up at the top, I have my answer and remainder 8. So if we were going to write this as it would be written in the division algorithm, we would write, oops, sorry about that, we would write x to the sixth, let's see, minus 3x to the fourth plus 2x cubed minus 5x plus 7 is equal to x to the fifth minus x to the fourth minus 2x cubed plus 4x squared minus 4x minus 1. Whoops, that got a little messy over here. Let me write that again. 4x minus 1 times, sorry, I ran out of room, x plus 1 plus my remainder is 8. And so this whole thing underlined in red here, that's my q of x business, that's my quotient. And this 8 right here, that's my r of x, that's my remainder.